Hello everyone, and welcome to our newest video. Today we will be covering systems of linear equations in 3 variables. Okay, now this one's a little more complicated than in 2 variables. So I wrote down some steps as guidelines to help you go through it and solve it a little bit easier. Okay, still going to take practice, but hopefully these will help. Okay, so your systems of linear equations in 3 variables. Your first step is you're going to write all equations in standard form, which means all your variables are going to be on the left, all of your just single number values are going to be on the right. Okay. Your second step, you're going to pick 2 equations and eliminate a variable. So you're going to do the exact same thing that you did for systems of linear equations in 2 variables, but you're just going to eliminate a variable to where instead of 3 variables, you're going to have 2. And I'll show you in the examples each individual step. Okay. Now for your third step, you're going to do the same thing for 2 different equations. So choose another pair of equations and eliminate the same variable that you did in step 2. Okay, step 4, you're going to use elimination or substitution to solve for those 2 variables. So the ones you didn't eliminate, you're going to solve for them. And your 5th step, you're going to use the solutions from step 4, those 2 variables that you solve for, use the solutions from step 4 to solve for the last variable. And your 6th step is to check your solutions by plugging them in, which is strictly optional. You can do that if you like, but it is recommended if you're not sure about your answer. Okay. Let me dot that I there. All right. So I'm going to go ahead and move on to the first example. If you still have to write these down, please feel free to press pause. But I'm going to go ahead and move up to our first example. Okay, bring that back down. Here we go. Okay, so let's say for our first example, we are going to solve x plus y plus z equals 500, 5x plus 10y plus 15z equals 4,750, and 8x plus 16y plus 25z equals 7,700. And we'll call this one equation 1. This is our equation 2. And this is our equation 3. Alright, so we're going to go ahead and start on this one. Okay, so for our first step, we have to make sure they're all in standard form. This one already in standard form. The x, y, and z are on the left side, the numbers on the right. Same thing here, x, y, and z is on the left, number on the right, x, y, and z on the left, number on the right. So it's already in standard form. Okay, so your second step, you're going to pick 2 equations to add together. You want to eliminate a variable. So you can pick any one you like. So for this one, I'm just going to pick 2. So I'll pick equation. So we're going to add equation 1 and equation 2. And we're going to eliminate the x variable. It can be any variable at all. It doesn't have to be the x variable, but I'm just picking the x variable. To eliminate the x variable. Okay, so I'm going to pick these 2 and I'm going to eliminate the x variable. Okay, so we have equation 1, which is x plus y plus z equals 500, and equation 2, which is 5x plus 10y. Maybe should line that up a little bit better. I just like having my x, y's, and z's lined up so that adding them is a little bit easier. So you have x plus y plus z equals 500, and 5x plus 10y plus 15z equals 4,750. Okay. Now, in order for these to cancel out and eliminate the x value, if this is 5x, equation 1 has to be negative 5x. So that means we have to multiply each of these terms by negative 5. Okay, so we're going to go ahead and multiply each of those terms by negative 5. Okay, so instead of rewriting them with a negative 5 next to them, I'm just going to put the negative 5 right above them. All right, so we're going to go ahead and go to our step where we're going to jump ahead and multiply those. So negative 5 times x is negative 5x. Negative 5 times y is negative 5y. Negative 5 times z is negative 5z. And negative 5 times 500 is negative 2,500. Okay, so we went ahead and multiplied each term by negative 5. And the second one, we're just going to write that down the way it is. 5x plus 10y plus 15z equals 4,750. Okay, so just like we did for 2 variables, we eliminated 1. Okay, now we can go ahead and add them together. Okay, so negative 5 and 5 cancel each other out exactly how we planned it. Okay, negative 5y plus 10y is positive 5y. And negative 5z plus 15z is positive 10z. And negative 2,500 plus 4,750 is 2,250. Okay, so we're good. We eliminated one of the variables. So we're good there. Okay, now we go to our third step where we pick 2 other equations and eliminate that same x variable. That's the key. You have to eliminate the same variable you did in the second step. So our third step, let's say we add equation 1 and equation 3 to eliminate the x variable. Okay, now the reason I keep picking equation 1 is because it's just an x. So x, y, and z, it's easier to multiply something to get it to be negative 8 and negative 5 than it would be to match these two up. So that's why I picked equation 1. Okay, so if we go ahead and write down equation 1 and equation 3, sorry about that, we will end up with x plus y plus z equals 500. And equation 3 is 8x plus 16y plus 25z equals 7,700. Okay. Now we can see here, if we're going to eliminate the x, then this 8x here will have to cancel out a negative 8x up here. So that means we're going to multiply each term by negative 8. Multiply each by negative 8. Okay, so I'm just going to put a negative 8 above each of them. Remember, you want to do each term. Alright, let me bring this up a little bit. Now you will most likely need a second sheet of paper because these can get a little lengthy. Alright, so if I rewrite it, after multiplying by negative 8, you have negative 8 times x, which is negative 8x. You have negative 8 times y, which is negative 8y. You have negative 8 times z, which is negative 8z, equals negative 8 times 500, which is negative 4,000. Okay, and the second, well, equation 3, we're just going to go ahead and write that down. So you have 8x plus 16y plus 25z equals 7,700. Okay, and just like before, we go ahead and add them together. We'll bring that up a little bit more. Okay, so negative 8x and 8x cancel each other out exactly how we planned it. Negative 8y and positive 16y, that just becomes positive 8y. Let me clean up that y a little bit. So there we go. Don't want it to look like a different variable. Okay, negative 8z plus 25z is positive 17z, which equals negative 4,000 and 7,700 is positive 3,700. Okay, so that's our third step done. So you can see the second and third step are pretty similar. Okay, so now the fourth step, which we're going to continue on another sheet of paper, is we're going to get these two, and then we're going to use the system for solving in two variables to solve for y and z in both of those. Okay, so as long as you understood how to solve the system in two variables, that's exactly what you're going to do here. So that was the point of steps 2 and 3, would be to get rid of that third variable temporarily and figure out the two variables that we learned how to do in the previous video. Alright, so I'm just going to write continued here. Okay, and if you're still writing, feel free to press pause, but we're going to shift to another sheet of paper and continue this problem. Okay, slide that back down. Alright. And write our continue there. Alright, so right now, if we go ahead to our fourth step, we're going to write down our answers from step 2 and step 3, which is 5y plus 10z equals 2,250, and 8y plus 17z equals 3,700. Okay, now you can eliminate whichever variable you like. You can eliminate the y first, or you can eliminate the z first. I'm just going to go ahead and eliminate the y. No specific reason, but the values are simpler. Okay, so for this one, these two have to match. So you can't just multiply this by negative 5 and have it cancel out. So this is one of the examples where you'd have to multiply both numbers. So this one, you're going to multiply each term by -8. Okay, and this one, you're going to multiply each term by +5. Okay. Now you'll see why I did that. And I'm just going to draw that there. So if we multiply each term here by -8, we have -8 here, and I'll just put a -8 there, and a -8 there, and each term here by 5. So we'll go ahead and put a 5 there, 5 there, and a 5 there. And we go ahead and rewrite it. So -8 times 5 is -40. So you have -40y. -8 times 10 is -80. So -80z equals -8 times 2,250, which is -18,000. Okay, so now we're going to do the same thing to our next equation. 8 times 5 is 40. So we have 40y. 17 times 5 is 85. So we have +85z equals 5 times 3,700 is 18,500. Okay, so now we can go ahead and add those two together. And lo and behold, our y's canceled out just like we planned it. Okay, so you have -80 plus 5, which is +5. Well, plus 85 is +5. So you have 5z equals -1800 plus 18,500 is 500. Okay, so if we divide both sides by 5, oops, that was a little messy. Let me clean that up some. Okay, anything divided by itself is just 1. So we end up with z equals 500 over 5, which is 100. So we have our first answer. Okay, and if you remember from our system in 2 variables, once you solve for one of them, you just plug into either and solve for y. Okay, so you plug into either one of those 2 variables to solve for y. So if we have 5y plus 10z equals 2,250, that gives us 5y plus 10 times 100 equals 2,250. Or just 5y plus 1,000 equals 2,250. So if we subtract 1,000 from both sides, we end up with 5y equals 1,250. So if we divide both sides by 5, we get y equals 250. Okay, so we have our x and we have our y. Okay, so now we go for our 5th step, which means we get our y, we get our z, and we plug it into any of our original equations to solve for x. Okay, so we go for our 5th step. So we'll plug y equals, that's a little messy. There we go. Clean that up some. Bring that up a little bit for you. So we'll plug y equals 250 and z equals 100 into any of our original equations. To solve for y. Solve for y, solve for x. Sorry about that. Okay, so of course I'm going to pick equation 1. That's the easiest. Just x plus y plus z equals 500. So of course, if you want, you could pick any of the other two equations. Just won't be as simple. So you want to pick the simplest equation to get your answer. Okay, so that's x plus 250 plus 100 equals 500. Or we can go ahead and combine those two and get x plus 350 equals 500. Subtract 350 from both sides, and we end up with x equals 150. Okay, so your answers will be x equals 150, y equals 250, and z equals 100. That would make all three of those original equations in this system true. Okay, now if you had to write that in another way, you have to write it as an ordered triple. You have an ordered pair, which is your x comma y. You have an ordered triple, which is your x comma y comma z, or just 150, 250, and 100. Where this is your x, your y, and your z. Oh, slide that up a little bit. There we go. Okay, so depending on how they want you to write your answer, these would be your two ways to write it down. Okay, so hopefully that made sense. Okay, if you're still writing, please feel free to press pause and continue writing. But we're going to go ahead and go to our next example. All right, bring that down a little bit. All right, so let's say for our next example, we wanted to solve 3x minus y plus z equals negative 15. If you have x plus 2y minus z equals 1, and 2x plus 3y minus 2z equals 0. Okay, so you have equation 1, equation 2, and this is our equation 3. And I'll go ahead and just group those together. You don't have to have that little brace there, but it's just my personal preference. So, all right. Now remember our first step. I'm going to go ahead and solve this one. First step is to put it into standard form, but it's already in standard form, so we're good there. All the x, y, and z variables are on the left. All the non-variable terms are on the right. Okay. So it's already in standard form. Okay. Now for our second step, remember we have to add two of those equations together to eliminate one of the variables. Okay, now this one is probably the simplest equation, so I'll probably use this one and add it to equation 1 and again to equation 3. Okay, so for our second step, we're just going to add equation 1 and equation 2 to eliminate the z variable. Now I picked z because if you add these two together immediately, you don't have to do anything to them. They're going to cancel each other out naturally. So that's why I picked the z. But if you wanted to, you could pick the y and multiply each by 2. Doesn't matter at all where you start. Okay, I just like to look at it and figure out which one would be the least amount of work. Okay, I admit it, I'm a little bit lazy. Most mathematicians are. But that's why I picked the z. Okay, so you have 3x minus y plus z equals negative 15, and x plus 2y minus z equals 1. Okay, don't have to multiply anything. We just go ahead and add it together. It's just a beautiful thing. Because those two cancel each other out right off the beginning. Okay, so you have 3x plus x, which is 4x. You have negative y plus 2y, which is just plus y, equals negative 15 plus 1 is negative 14. Okay, so we can go right into our third step. Where we add equation 2 and equation 3 to eliminate z. Okay, remember you have to eliminate the same variable in steps 2 and 3. Otherwise it won't work. Excuse me. Okay, so if we write down equation 2, x plus y minus z equals 1, and we write down equation 3, I forgot one of my parentheses up there, 2x plus 3y minus 2z equals 0, we see here in order for the z's to cancel out, we have to multiply this by negative 2 to make it a positive 2, because we need positive z, 2z, and negative 2z. So we multiply each term by negative 2. Bring that up just a little bit. Okay, so if we go ahead and multiply each of these by negative 2, I'll just write a negative 2 above each term, so we'll know what we're doing. Go ahead and write it down. So negative 2 times x is negative 2x. Okay, negative 2 times y is negative 2y. Oh, that should be 2y. Sorry about that. I'm glad I looked up and double checked that. I'm sure many of you were yelling, "You forgot the 2! You forgot the 2!" Okay, I have my 2y. X plus 2y minus z equals 1. Okay. For those of you yelling through the screen, I heard you. I felt the vibes. Okay, so instead of negative 2y, that should be negative 4y plus 2z equals negative 2. And then we have 2x plus 3y minus 2z equals 0. Okay, so we can go ahead and add those two together. And here an interesting thing happens. We have negative 2x and 2x. That cancels out also, along with our positive 2z and negative 2z that we originally thought was just going to cancel out. Okay, so we got a little bonus there, because negative 4y and 3y is just negative y equals -2. Divide both sides by -1 or multiply by -1. And we end up with y equals 2. Okay, that's interesting because if we know that y is equal to 2, it'll be really easy to solve for x here. Because we just plug in y equals 2 and our x is right there. We don't have to add anything together. We don't have to do the system of linear equations in two variables. That made it a whole lot easier for us. Okay, so we're running out of, well, actually we can do the fourth step on this page. Okay, so the fourth step, we're going to go ahead and get those two. So we have our second step and third step that we go ahead and add together. So really we have 4x plus y equals -14 and y equals 2. So bring that up a little bit more. There we go. Okay, so all we have to do is plug in there. So replace y with 2. So that means we have 4x plus 2 equals -14. We have -2 and -2. So 4x equals -16. Divide both sides by 4. And we have x equals -4. So that one was a little bit easier. Okay, so we have our y and we have our x. We're going to continue that on the next sheet. Okay, so for our fifth step, we have our x and we have our y. So we go ahead and plug that into any of our original equations. And we solve for z. Okay, so if you're still writing, please feel free to pause and finish up. But we're going to go ahead and move to our conclusion of this problem. Alright, so we're going to go ahead and continue here. Okay, so we know that x is equal to -4 and y is equal to 2. Okay, so we're going to plug x equals -4 and y equals 2 into any original equation. To solve for z. Alright. So we'll pick x plus 2y minus z equals 1. So we plug those in. That gives us -4, replacing x with -4, plus 2 times 2, replacing y with 2, minus z equals 1. So here we get -4 and 4, which cancel each other out because that just equals 0. So we have -z equals 1, but we don't want to know -z, we want to know z, so we divide both sides by -1. So we have z equals -1. Okay, so you have your x, your y, and your z. So your answer, if you have to write it as an order triple, is -4, 2, -1, which is your x, y, and z. Alright, so hopefully these steps are starting to make a little bit of sense. Okay, so let's do another example. If you're writing, please feel free to press pause. But we will go ahead and continue on. Alright, so let's say for example, we want to solve, say, x plus y plus z equals 50. Say 3x plus 9y plus 9 equals 300. And let's say y equals x minus 15. Okay. Now this is another situation that the question is a little different. Okay, let me put those together. So remember your first step. You have to put it into standard form. Okay, now this one's not already in standard form like the previous examples. This one we have to subtract x from both sides. Okay, so we have x plus y plus z equals 50. Okay, we have 3x plus 9y plus 9z equals 300. And if we subtract x from both sides, we have negative x plus y equals negative 15. Now, if you wanted to, you could also divide each of these terms by 3 and simplify that. But I'm not going to, but you could, just to make it a little bit easier. Okay. Now, this one's different because if you notice, there's no z variable for this one, which is actually a very good thing for us. Because if there's no z variable, we don't have to eliminate a z variable. So that means our second step is done for us before we even start it, because we could just pick this as our second step. Because remember, your second step is to eliminate a variable. It's already done for us. So if you see one with a missing variable, they just helped you out. Okay, so we are just going to use negative x plus y equals negative 15 as your step 2. Since the z variable is already eliminated. Okay, so we are already good on step 2. Okay, so now we're going to go ahead and go to our third step. And in this one, we'll add equation 1 and equation 2 to eliminate z. And actually I didn't put equation 1, equation 2, and equation 3, but I'm pretty sure you all picked up that already. So add equation 1 and equation 2 to eliminate z. Okay, so that means we have our equation 1, x plus y plus z equals 50, and our equation 2 is 3x plus 9y. Oh, that should have been 9z up there. I'm pretty sure some of you yelling, "You forgot the z! You forgot the z!" I felt the vibes again. Plus 9z equals 300. Okay, so let's say if we're going to eliminate the z, we have to make that negative 9z. So multiply each term by negative 9. Okay, so we're going to go ahead and multiply each by negative 9. We'll just put the negative 9 above each term. Okay, and I do that because it's really easy to remember to multiply the left side and forget the right. So I'll put that -9 above each term. It may seem really, irrelevant, but it has a purpose. That's because really easy mistakes can happen when you don't do little things like that, at least for me. Okay, so to avoid making those little mistakes, I put little reminders right there. So that's why I put the negative value that I'm going to multiply right above it. Okay, so you have -9 times x, which is -9x. You have -9 times y, which is -9y. You have -9 times z, which is -9z, equals -9 times 50, which is -450. Okay, so here you have 3x plus 9y plus 9z equals 300, and we can go ahead and add those together. Okay, so interesting thing about this one, you have -9 plus 3 is -6x. -9 plus 9, the y's cancel out. -9 plus 9, the z's cancel out. So -6x equals -450 plus 300 is, oh, not -450, -150, duh. Alright, so we have -150. So if we divide both of those by 6, so -6x equals -150, and divide both by -6, we have x equals 25. Okay, so once again, this really helped us out, because if we know that x is equal to 25, we can kind of jump ahead a little bit, because we have our step 2 and our step 3 answer. Okay, so I just go ahead and wrote continue on the bottom there. Alright, so if you're still writing, by all means, press pause, but we're going to go ahead and finish up this problem. Alright, so we're going to continue that with our 4th step. So we have -x plus y equals -15, and we have x equals 25, which means we can solve this one by substitution by just plugging in x equals 25. So that means we end up with -x plus y equals -15. That becomes -25 plus y. I don't know why I put the parentheses there. Equals -15. That was completely unnecessary. So, well, not really, since the negative was already there. You don't need it, but I think I just put it there out of habit. Okay, so if we add 25 to both sides, we have y equals -15 plus 25, which is +10. Okay, so we have our x equals 25, our y equals 10. Now we just plug in and solve for z. So plug in x equals 25 and y equals 10 to any original equation. Okay, so of course I'm going to pick the x plus y plus z equals 50 because that's the easiest. Plus z equals 50. So if we go ahead and replace these values, we have 25 plus 10 plus z equals 50. Go ahead and combine those two. which gives us 35 plus z equals 50. So if we subtract 35 from both sides, we end up with z equals 15. Okay, so we have our x, our y, and our z, but if you have to write it as an ordered pair, we have 25, 10, 15, or your x, your y, and your z. So move that up a little bit. There we go. Okay, so that is it. Your answers have all been set. Hopefully the steps made sense. Okay, if not, go back, replay the video, answer the questions by yourself, see if you can answer them. Okay, now if you look for the next video, it will explain inconsistent and dependent systems of linear equations, so be on the lookout for that one.